Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hakim bin Muhammad Zainuddin. Matrix number AA200502. Today, I will explain about welding work. Firstly, we must know what is welding. Welding is the use of heat or pressure to join metallic or non-metallic materials. Welding can be done in variety of ways. Among the identified welding methods are flame welding, high voltage electrical energy, laser radiation, electron firing, friction welding, and ultrasound. We can be done in a variety of environments, including open areas, underwater, and in outer space. Despite the fact that it is typically a manufacturing process, welding is a potentially hazardous activity, and precautions must be taken to avoid burns, electric shocks, visual damage, inhalation of toxic gases and fumes, and ultraviolet radiation exposure. There are four main types of welding. First, MIG or gas metal arc welding, GMAW. TIG, gas tungsten arc welding, GTAW. STIG, shield metal arc welding, SMAW. And flux core arc welding, FCAW. Welding operations pose a number of risks to both those performing the work and those nearby. As a result, it is critical that we are aware of the risks and hazards that welding presents, as well as the precautions we take to protect ourselves. So, for the safety and precautions, firstly, we need to always wear appropriate personal protective equipment or PPE. When performing any welding activity, it is critical to maintain high levels of safety. Ignoring our PPE and safe working practices can have serious consequences, even resulting in fatalities. Obtain appropriate training. Before beginning any welding work, it is critical that us to receive adequate training in the use of safety of our equipment. Next, make certain that our workspace is well ventilated. When welding, good ventilation is essential because it removes airborne gases and particles from the work area. To combat all of the pollutants produced during the welding process, we need to use a combination of ventilation strategies. If the ventilation strategies do not reduce our exposure sufficiently, we may need to use respirators. Lastly, make certain that our workplace is free of flammable materials. Avoid storing flammable materials near welding process because sparks, heat, and molten metal splatters produced during the welding process have the potential to ignite flammable materials. So, for the welding equipment, what we need is first, welding shield or helmet, protective clothing, welding machine, electrode holder, welding leads, cable locks and connector, chipping hammer, and wire brush. So, what is shielded metal arc welding? Once more, shielded stick welding is simple yet versatile, low cost and portable welding method. Flux coated welding rods are used, which eliminates the needs for bottled shielded gas, which is used in TIG and MIG welding. Stick welders are ideal for welding in the outdoors and or on rusted or dirty objects. A stick welder can join most common metal and alloys. So, for the procedure, firstly, make sure the arc welder in good and safe condition and the power supply can be used before proceeding with welding work. Next, switch on the power supply and then switch on the welding machine. And then choose the right current and polarity. At the points where welding is to be carried out, the points are marked by the arc. The welding is carried out by contacting the electrode with the workpiece and then separating the electrode and suitable distance in order to generate an arc. When the arc is generated, the intense heat so generated melts the workpiece under the arc and forms a molten pool. A small indentation is formed in the workpiece, and the molten metal is deposited around the edge of this indentation. And lastly, slag can be easily removed after the joint has cooled down. So, for the factors to consider when choosing the best stick electrode are: first, welding rod selection. Stick electrodes come in a variety of shapes and size, each with its own set of mechanical properties and operating with a specific type of welding power source. When it comes to welding rod selection, there are several factors to consider, which is first, base metal properties, tensile strength, welding current, base metal thickness, shape, and joint fit up, welding position, specification and service conditions, and environmental job conditions. So for the base metal properties, the first step in selecting an electrode is determining the composition of base metal. The goal is to match the electrode composition to the base metal type, which will aid in the formation of a strong weld. When working with a broken part of component, look for a coarse and grainy internal surface, which indicates that the base material is cast metal. Or if the base metal is magnetic, the base metal is not most likely carbon steel or alloy steel. If the base metal is not magnetic, it could be manganese steel, 300 series austenitic stainless steel, or a non-ferrous alloy such as aluminium, brass, copper, or titanium. Welding position. Refer to the third digit in AWS classification to determine what positions a specific electrode is for. Here, how to figure out the qualified electrode position. So, 1 represents flat, horizontal, vertical, and overhead, and 2 only flat and horizontal. Let's say for the example, a 718 electrode can be used in the flat, horizontal, vertical, and overhead positions. So, for shielded arc or heavy coated electrode, run the arc. This welding electrode creates a reducing gas shield. This prevents the weld metal from being contaminated by atmospheric oxygen or nitrogen. Because oxygen readily combines with molten metal, alloying elements are removed and porosity is created. Brittleness, low ductility, and in some cases low strength and corrosion resistance are all caused by nitrogen. They reduce impurities such as oxides, sulfur, and phosphorus so that they do not interfere with the weld deposit. They add substance to the arc, increasing its stability. This eliminates white voltage fluctuations, allowing the arc to be maintained without excessive spattering. So, in this result, we can see the defect causes, which is porosity. Defects are common in all forms of manufacturing, including welding. The shape and size of the metal structure may vary during the process. It can be caused by using the incorrect welding process or the incorrect welding technique. So, what is defect? What is porosity defect? Entrapment of gases in the weldment causes porosity, and other cavities such as wormhole and blowholes. Internal and volumetric defect are the two types. Okay, porosity is caused by wet metal contamination, the entrapped gas from bubble-filled weld, which weakens and eventually collapses. Porosity is caused by a variety of factors, including inadequate deoxidant for the electrode, using a wider arc, the presence of moisture, inadequate gas shield, inappropriate surface treatment, excessive gas flow is used, surface contamination, rust, paint, grease, or oil are all present. To fix this defect from happen is firstly, before we begin welding, clean the materials. Next, dry electrodes and materials should be used. Use the proper arc distance. Examine the gas flow meter and ensure that it is properly configured with pressure and flow settings. Next, reduce the arc travel speed, allowing the gases to escape. Use the appropriate electrodes and use the correct weld technique. And last but not least, after finishing the work, switch off the supply welding machine and quickly take out the electrode holder, and make sure to keep clean the welding machine and environment in the workplace. That's all from me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.